So we'll discuss here a solution of a tutorial 5. Tutorial 5 is on beta and gamma function. Yes, it is one of the lengthy tutorial because near about 8 questions plus 2, there are total 10 questions I given. Okay, definitely it will help you to solve the examples in IMU and exam as well as in CT2. Okay, CT2 you will find similar questions there. So all possible variety of the examples considered in this tutorial. So it is enough to practice the questions from tutorial and PPT. Okay, for your understanding. If you do these examples, yes, remember you can solve any example of a beta and gamma there. So we'll start with this question 1. So the question 1 is just evaluate the integral. The most important thing in beta and gamma is the identification. You should be able to identify whether the example is on a beta or the example is on a gamma there. Okay, so that is the main thing. So there are a few questions here. Let me discuss one by one. So the question 1, can you tell me whether it is a beta or a gamma? This first one.
So gamma.
This is of a gamma, correct. So why it is a gamma? Because of the term, this one. E raised to, just a minute.
Sir, exponential term.
Correct, exponential term. Just a minute, pen is not working. That exponential term, correct. So this one, e raised to minus 4x square. So what should be the substitution? What should be the substitution for this?
So 4x square.
4x square is equal to t, correct. And this example already told it is of a gamma. Good. The first thing you identified it is a gamma and 4x square equal to t. It will simplify and I will show you the final answer. The final answer you should get it for this is this one, 1 upon 32, 1 by 32. Okay, if anyone have a doubt, then we'll solve it completely. But I think it is a simple example. All you can do that first question, gamma. So that about first question. Question number 2 is of which type? Question 2. This one. Yes, I'm not able.
Gamma.
Again, gamma, very good. And what should be the substitution?
So the whole term.
Whole log of 1 by x can be taken as a
Sir,
t.
I tried one more method. Sir, I
Yes.
simplified it, sir.
Okay, that is okay now. So you can use the properties of logarithm and you can write log of 1 by
Sir,
x as a minus log x.
sir, actually, yes, sir, there is, I was facing problem in the sign, sir. I was getting one minus instead of the answer being positive.
No, 1 minus sign, it is used to change the order of limit there. Okay.
No, sir, even after that, maybe, sir, I was doing some mistake. If you could
Yes,
show
probably.
the sum in that method.
No, see, if I want, I can solve it my way. But if you want the mistake from your calculation, you can share it on the WhatsApp and then I will tell you where you made a mistake. Okay.
Okay, sir, I'll
Okay.
share, sir. Okay.
Yes, that's better. So that about the second question, log of 1 by x as a t, and it again reduces to the gamma in the standard form as a 0 to infinity. What about third? Third example is of which type? This third one. This is again of a gamma. And what should be a substitution? What should be the substitution for third? Too much time all you are taking. Huh?
Sir, a to the power x, 3 to the
Where
power
is
x.
3 raised to x? 3 raised to x
3 to
should be
the
t, and that
Yes, sir.
converted, that can be converted in the gamma form then, correct. That about third. What about fourth?
Sir, it is beta.
It is a beta, good. So this is the first question which is on a beta, and you'll observe only algebraic terms present there in the form of x raised to n into 1 minus x term. So that is a beta, and always you have to look for the bracket for the substitution. And what should be the substitution here?
So 4x square.
4x square equal to t, correct. So that about the fourth question. So fourth question, you can do it with a beta. We can convert in a standard form of a beta by the substitution 4x square equal to t. That's correct. Fifth question.
So
Sir,
gamma.
x square equal to t.
Gamma, correct. So and a square x square equal to t. That is correct substitution again. Yes, someone given a square x square equal to t. So that is the fifth. Sixth. Yes, sixth question.
Beta.
It is a correct identification. We can do it by beta, but it is a trigonometric form of a beta. Remember, it is a trigonometric form of a beta, but it is yet not in a standard form. For standard form, we should have 0 to pi by 2 sine raised to p theta into cos raised to q theta. That form should be there. So how to write it in the standard form? What should be the substitution?
3 theta is equal to t.
Correct. First, 3 theta equal to t is the correct substitution, which converts to cos cube t and sine square 2t there. But sine square 2t also we can simplify as a 2 sine t cos t, and then we get a power of sine and cosine only. And then we use that formula, integration 0 to pi by 2 sine raised to p theta into cos raised to q theta d theta is 1 by 2 beta p plus 1 upon 2 and q plus 1 upon 2. So that way we have to complete it. Okay, so there are first thing, proper substitution, which gives us the correct limit. The limit should be 0 to pi by 2. Then only we can apply the beta. At the end, if the power of sine and cosine is integer, suppose sine raised to p theta and cos raised to q theta are there, and p and q both are integer, remember you have a choice. You can either do it by beta or you can do it by Wallis formula. Okay, so whenever integer power is there. But if a fraction power is there, there is no alternative other than the beta. So you have to only use a beta for fractional power of trigonometric terms there. Okay, that about sixth. What about seventh? Which form? Seventh, yes.
Beta.
Seventh is not a beta,
Gamma.
it is a
Gamma, sir,
gamma
gamma.
only. Seventh is of a gamma, and we have to take log x equal to t. Log x equal to minus t. Okay, so this we already discussed. This log x is equal to minus t there because x log x bracket cube is there. So if we take log x equal to minus t, we get a gamma form. And what about eighth?
Sir, beta.
Beta. And what should be a substitution?
X square is equal to sine theta.
X square equal to sine theta. Yeah, you can go that way, but no, only sine square theta will not work. So if you want to go in a trigonometric form, you can put x square equal to 2a sine square theta. X square equal to 2a sine square theta. That may be, no, no. It is better. Why you make complicated? It's a simple substitution will work for beta. What happens? You will take x as a common from the root there. You will left with root x into root of 2a minus x, is it? And then you can put x equal to 2at. Okay, or in this directly also you can replace x equal to 2at. It will convert to the first form of a beta. So the last example, you can do it with x equal to 2at substitution, and that is of a beta. Now just only three questions are there. There are only three questions, question 4, 6 and 8 from the beta, remaining are of a gamma. We already discussed how to identify whenever whenever that integrand contains exponential term e raised to x or a raised to x or a log x term. Remember that example can be solved by a gamma. Otherwise, when trigonometric terms appear, sine theta, cos theta, or only algebraic terms appear, you can solve it by a beta there. Okay, and their answers now. I will show you the answers of all these questions. Here are the answers for the first 8. So all the questions along with the answers I shared with you now. I hope everyone can cross check your answers. Answer of the 7th is a negative there. It is a minus 3 upon 128. Okay, that way. So your answers can be in a beta form like this question 4, provided the question is for 2 marks, but generally it is expected your answer you should write in the number. You should simplify and write it in the number form. Convert beta to the gamma and write the final answer there. So that about the question number 1 there. Okay, question number 1. Now if we come to the question 2 here, question number 2, the question is expressed this in the form of a gamma. Can you tell me the substitution for this question number 2 now? How you can write it in the gamma form?
Sir, x square is
X
equal to
square.
sine theta.
X square equal to
Sine
And
theta.
theta.
Okay, good. So that is one of the substitution, x square equal to sine theta. If you put x square equal to sine theta, it will convert probably in the trigonometric form of a beta. And once you get a beta, you can convert beta to the gamma. That is one of the way. Or there is another substitution. There are two substitutions. One substitution, yes, some already x square equal to sine theta given. This will work. Yes, correct. This will work and gives you a trigonometric form. But we have one more substitution that can be taken, x4 equal to just t. This will give you the algebraic form of a beta. So both are correct. Either use a trigonometric form or algebraic form, get the answer in a beta, and then you can convert in the gamma form. Okay, and your answer will be, okay, your answer will be for this question number 2 is this one, 1 by 4 beta 1 by 4 comma 1 by 2. And if you convert into the gamma form, the answer is a root pi by 4 gamma 1 by 4 upon gamma 3 by 4. You have to keep as it is. No need to simplify. Okay. Yeah, we can simplify by, if there are some standard values, you can keep as it is. But and now here, that last question that many of you have a little bit issue. The reason is obviously that property I not told, because that property is not a, we can say it is not that much depth of the syllabus we have. So definitely the chances are coming to use that property in exam. Okay, but remember this integral, individual integrals can come as an example in the exam, that evaluate this integral and evaluate the second integral separately. So the first thing that you will observe that we have two integrals that we have to evaluate. Okay, so say the first integral is say I1. What should be the substitution for this I1? What should be the substitution?
Sir, x cube.
X cube equal to t, correct. And then we have one more integral, say this is I2, and for I2 we can simplify with substitution y raised to 6 equal to t. Is it?
Yes, sir.
Can anyone tell me what the value you got there for this I1 and I2? So this is a yes, anyone?
Sir, I1 is equal to 1 by 3
Okay,
gamma 1 by 6.
gamma 1 by 6. Okay,
6.
ठीक. Next, I2
I2 1 by 6
1 by 6.
gamma 5 by 6.
Correct. So this is the value of I1 into I2. I1 into I2 is equal to this one. Up to this, everyone done. I know that is 1 by 18 gamma 1 by 6 into gamma 5 by 6. Now the problem is,
Sir,
yes,
sir, can't we, sir, convert 1 by 6 into gamma 1 by 6 using the property, and it will convert to gamma
which
7 by
property?
6.
Which property? Tell me.
Sir, gamma n plus 1 is equal to n gamma n.
So can you write this 5 by 6 as n plus 1 form? It can't, because numerator is less than
Sir,
denominator.
sir, I'm talking about 1 by 6. 1
Huh?
by 6 and gamma 1 by 6.
So okay, 1 by 6 into gamma 1 by, yes, you can 1 by 6 into gamma 1 by 6 can be written as 1 by 6. So but you will get just gamma 5 by 6, but how you will reach to the pi by 9 there? Okay, that is okay.
That is
Yes,
difficult.
your thinking is correct, but actually that way we don't have the required answer, pi by 9. There is only one thing that is missing here, or that I not told you while completing this topic, that there is one property, and that property is a gamma n into gamma 1 minus n is pi upon sine n pi. So this is one more formula that you have. There are 2-3 formulas which generally used for simplification. This is one of that. There's another is a duplication formula is also there. But no need to go in the detail, because that depth is not for us in our syllabus. So in this property, we consider right now without proof. Okay, this property is there. Maybe name is there, like Euler's property or something. You check that. Just replace n by 1 by 6. If we replace n by 1 by 6, we get gamma 1 by 6 into gamma 5 by 6 pi upon sine pi by 6. Because n is 1 by 6. N is 1 by 6. So sine pi by 6, 180 upon 6, that is sine 30. What is sine 30? What is the sine 30?
1 by 2.
It is 1 by 2. So the answer of gamma 1 by 6 into gamma 5 by 6 is a 2 pi. So if you replace that value 2 pi here, 180 into 2 pi, we get the required answer as a pi by 9 that way. So this way you can finish this. So that is the required answer. But yes, obviously this property you have to buy her then for this if you have to do this question. Okay.